So today we're gonna talk about Landlock Rulesets, how to use Nono to set this up, and I'm going to cover pretty much just the basics of Nono and show you how we use Nono with Grate to implement this, create several profiles that we extend the base profile from. And you'll pretty much learn how to use the command line to test some permission. You'll learn about diagnostics, how to disable them for production, and some few other details. Okay, let's get into it. So we're gonna talk about how we use Nono in Grate. So we use what we call custom composable profiles, which pretty much means that we've got a bunch of tiny profiles for GPU support, for supporting C development tools, and then we use this to extend the basic Grate profile, which is the actual profile that we load. We also extend the basic profile with the open code profile when we are running open code and stuff like that. So we essentially just do directory and file access control, and we do basic TCP UDP access control from our whitelist. So let's take a quick look just at our whitelist. So as you can see, we are allowing a bunch of common websites like Hugging Face, domains, all with TLS. We allow GitHub, and we allow a few models from open code as well. And open code, if I'm not mistaken, will try to contact these three when it opens, and if they are not allowed, it will take a little while longer to load without any any feedback on this, which is also interesting. I'm not sure if one of these is due to the Nono plugin, which gets automatically installed for open code, but anyway, this one is really required to just use open router models. So we will be reading this file. We've got something out that runs this automatically to extend the Grate profile. So let's take a look at our profiles. So our profiles are this Grate JSON, which is the default profile. Our Grate CDev is the extension that we can use for C development tools, and this is the one for the GPU. Once these are combined, they will be rendered on runtime using the Nono wrapper. So the Nono wrapper will take care of all of this, and as you can see, we've got paths to each profile. They get copied during image build, and then if these flags are enabled on the entry point for one specific image that uses our base image as the base, then the profile will be extended using this try extend profile. And essentially it just checks if the files are readable and writable as required, and it uses JQ to extract the name of the profile that we want to extend from. Might be the GPU one or the CPU one, and then it adds to the extends entry on our main Grate JSON profile. So let's take a look at this Grate JSON. In here, as you can see, it only includes the default profile, so it extends from default by default, and then it can add GPU or maybe open code dynamically as required. Okay, so as you can see, we've got this extends, we've got some metadata, the name for the profile, short description. We need this allow GPU to be set here, otherwise you won't be able to access the GPU. We always enable it by default, although it requires access to some specific devices which are only defined on the GPU profile. Maybe we should add this dynamically as well when GPU is enabled, but it's there are many improvements because I only touched the surface of each tool yet. So in the file system object, we've got read file or write file for specific files. We can also do allow, I believe. But let's go into the Nono website, and under profile authoring for the documentation for the CLI, if you scroll down, you'll find the full skeleton where you get the full syntax for the profile JSON file. Okay, this commands allow, I think this is deprecated, and groups is just to create groups of permissions, which is something we could perhaps use instead of extends. And so maybe in the future I'll look into this. And as you can see, for file system you get allow, read, write, allow file. So these are for directories, these are for specific files, and then you get some for Unix sockets and to deny or whatever. Okay, and so you should consult this. You can also control set environment variables and control access to environment variables. But I actually use set vars, but I didn't use this much. By default, I believe all environment variables are inherited. And so as you can see here, I let it read the bash profile by default. I let it read the app directory and the certs directory because we've got SSL certificates and a root certificate that we created, and it's used with Llama. And I also allow read and write to /workspace and also /models because this is mounted and you might want to add your own model externally. For now, this is the way that I found to expose more easily the models, and then there's an environment variable that lets you set the model, but I haven't fully tested this yet. So if you want to be sure that this works correctly, instead use the build argument to set your own model, and it will be downloaded during build, and then it will be used by default in your own image, right? Then we've got our network. We allow the domain for our internal Llama host, so Llama server, because the Llama server opens the 8080 and 8443 ports. We also add rules for this. Since we need to connect from the container to the 8080 port from the 8443 port, we need to use open port, which is bidirectional. But for the SSL port, we only use listen port because it will be connected to externally, and we'll be able to find these here somewhere as well. As you can see, if you search for open port, I think we can use the CLI argument, which is the same thing. So open port allows bidirectional connections, while listen port just lets you open the port essentially, and doesn't allow connections internally from Nono. Okay, so this is a very basic profile, as you can see. But for instance, if we look at Grate GPU, now we've got a lot more stuff here, as you can see, right? And so I probably can even remove this allow GPU because I'm already extending from here. Maybe I just forgot to remove it. In here we are adding permissions to read a ton of stuff that got blocked, so I tested this manually with Nono, and Nono will tell you what is being blocked. So for instance, let's say that I remove let's say the GPU items here, and this will change for your GPU. Mine is on 3, but this changes frequently, so you might really need to edit this to replace with your GPU. So you might actually get this denied by default. let's try to do something with this, okay? So first I'll need to rebuild everything, okay? I don't need the CDev tools nor the debug tools. Well, hopefully let's at least include the debug tools, and this will build the image for open code as well. But now there is no permissions to access the graphics card, although we will connect the container with GPU access. But I believe Nono will show you an error, and in fact, while this is building, let it cache. Let's go into the Nono wrapper and let's remove this no diagnostics. Otherwise, we won't have the interactive output from Nono telling you what permissions were attempted and failed, right? So let's remove this. And I will have to rebuild this, but most of it will be cached because this only affects the entry point. So we just wait a little while for this to build, and I'll be back in a second. So I'm back. Before rebuilding with the changes that we just applied, let's first go into the container for Llama server, and I'm going to replace this entry point with just a shell, so that we can run this manually and you understand how we debug this. So this is Wolfie, so you get Ash, right? And we are going to run Nono wrapper with --GPU and using the Llama server. This is not critical, it's just some arguments, but I can also add them. It really depends on your setup, but I'm not going to go into the detail with all that. Let's build it again. And once we are done building, we will run start Llama server. Although I think this runs in detached mode, so I'm going to just disable that temporarily. Let's go into start Llama server, and as you can see there is a detach here, and instead I'm going to run this in interactive and with a TTY, so that we can enter the container. So let's run this. I need to be inside the Grate directory. Okay, and remember that we disabled the no diagnostics for Nono, and there is no Nono running, but if we cat user bin Nono wrapper, you'll see there is the no diagnostics has been removed. And so we will want to run this with user bin Llama server. We want to enable GPU, and I'm going to pass these command line arguments as well, just to make sure that it's able to load the model in my machine. Okay. Okay, and let's try to run it. Some reason there was a segmentation fault. Let's try to exit, and as you can see, it's asking for permissions for these two devices that I removed from the profile just to demo this to you. So let's cancel for now, let's exit, and let's go into Nono wrapper, and let's add back the no diagnostics. Let's just build. And once we build, we're going to enter Llama server again. Just going to copy the command that I run up here and see, and at least confirm that it won't be any interactive feedback like we got now. Okay, let's just wait a little bit. Okay, we are back. Let's now start Llama server, and let's try to run the same command. I'll need to copy it again. and as you can see, now there is no information from Nono, so that's why the node diagnostics is only used in production. If you need to debug, you should remove this, okay? And this will likely crash on your system, just because your device will be different from mine, okay? And you can just lspci and get these identifiers as well. So let's add this back. I'm going to quit and rebuild, and let's hope this is faster this time. I'll be back in a second. And we're back again. Let's start Llama server. I suspect that another Llama server is probably running. So let's check it. And that's the case, so let's just stop Llama server. This is why we were getting the segmentation fault, not because a permission was lacking, but it is enough just to demo this. It was enough what I did before. Let's try and run it now. I think the problem is that I'm using too much VRAM while recording with OBS, and so I don't have enough VRAM to run this. I don't know if I can maybe reduce the number of layers. Let's see. And yeah, if I reduce the number of layers, then I can open this, okay? And so that's pretty much how you debug with Nono. So you could, instead of the Nono wrapper, actually use the profiles directly. So if we go into Nono, you'll find several profiles here, okay? And you can simply use the Grate JSON profile, which is the version that adds the Grate GPU in here. I guess it's adding multiple times, which is also a bug, but it's not a problem anyway. I should clean this up, but it won't change anything, okay? So ideally in the future, some of these should be dynamically set. Your PCI Express device for the GPU probably can be detected using LSPCI and added here dynamically, and also the number of cores, you know, it tries to query each of these, and so I've got 24 cores, but for people who don't, maybe this will be will cause issues if it's a lower number. I'm not sure. Probably not, because the file won't exist, so it will never be accessed. But it's for, if it's more cores, we'll probably have an issue here. So maybe automatically detecting this and setting this would be interesting. We also have the CUDA libraries in here. We give it read access, and this is the only case where we use set vars, and this needs to be a certain version of Nono, because I was using an older one and set vars was fairly recent compared to the one I was using, so it was there was an error before, and then I updated to the latest version. I bumped it up, and so we have to set LD library to the path for open code, because to the path, sorry, for Llama server, because it's got some libraries that it will use, and also the paths for the CUDA libraries, okay? And without this, it wouldn't work correctly. For instance, for the CDEV file, for the CDEV profile, we do stuff like letting it read user include for the, you know, the header files in C. It can access the libs and all that. It can access the configs, although I'm not sure if this is mandatory. probably there are some GCC configs that live under etc. And then I also let it read these files, which is, as I told you before, there is really no execution permissions. There was a command entry, but that's been deprecated. So instead what you do is give it read file permissions. And so these are the required binaries that I only didn't need the C11 plus, which I think it's for C++. But I added it here because I noticed it was also available. I was just compiling C, but this with a little extension, this will work for C++ probably. Okay, and so this is the profile that we use for C, and maybe if we want to work with Python, we can create something similar for Python or similar for Go. Okay, let me check if there is anything else that is interesting to check out. So we've got our Grate JSON. As you can see, it is rendered here. We go through all the domains under the whitelist.conf, and then we add these domains to network allow domain. So if we go and cat, I'm not sure if I've got permissions for this. I think I do. So if we cat Nono Profiles Grate.json, you'll notice, so I just noticed a little mistake live, because as you can see, Grate.json only has the allow domain that I gave it by default. And what ended up happening is that although I render this Grate.json, and it should be available if we go into workspace and look at this, as you can see, all the domains have been added here. When I go into the base image building, I first copy this rendered version, then I copy all Grate profile. So this in fact overwrites the previous one. So what this should be is this, okay? And so there was a tiny bug here, but I didn't need to access these domains, that's why I didn't notice it. But anyway, this should be fixed from going forward. And let's go back to the just file just to see if there is anything else interesting about this. As we can see, when we build base, we render this Grate.json because it needs to be available. And that's pretty much it. I guess I covered all the bases. If you want to learn more about Nono, check the CLI reference for all the command line arguments that you get. As usual, they have a sidebar here. If you zoom out, and you can check all the flags that you can work with. If you want to open all the connections to the web, and in fact this disables the proxy completely, you can simply use the allow net flag. Okay, so this disables the proxy. We set the profile with -p or -- profile, as you saw. But most of all, this is about file system permissions. This is what Landlock supports, and it apparently supports an execute one. I don't know, but maybe Nono just doesn't expose this for some reason. And it supports these for network connections, TCP and UDP, and the Unix socket and signals ones. This for Unix socket is available on Nono. This I believe is not. So as you can see, the kernel API supports some extra features that the specific implementation, in this case Nono, might not support. So always take a look at the kernel documentation if you are delving deep into this. If not, at the very least, you should use Nono to secure your environment, either a container at the very least, and I would recommend maybe Nono even is even better than a container if you have to use only one. Okay. And that's it for a very tiny intro to Landlock and Nono. I gave you the pointers. Now you can check the documentation and should be able to extend on this. I also taught you how to debug the lacking permissions on Grate, so you need to do some tinkering and edit the container files to switch the endpoint and all that. It's not, you know, from a user experience point of view, it's not ideal, but it's what I can provide now. And like I said, this is not a tool, this is just my code that I'm sharing with you so you can learn as well. And so next time I will be covering, I believe, Seccomp BPF and teaching you how to, and showing you how limiting syscalls will affect your execution within your container. I'll see you next time.